ค่ะ
Hi, my name is Imelda and this is my group. Kayla, Jackie, and Joe.
Our goal was to get a rocket above in the air above 7 seconds.
The changes I made to my rocket were I added more water. I went from 800 milliliters to 1,000.
And for me, I changed my fins by putting them lower in my rocket and it went higher.
The changes I made to my rocket was the shape of the nose cone. It went from going pointy to slightly round, and it went higher.
I changed my rocket by putting a greater amount of water in it, and it went higher.
I tested the fins so to see if it can go higher than the last launch I did.
I tested my rocket by changing the shape and mass of my nose cone and how it could affect the launch.
I tested my rocket by putting more clay on it to see if it would go higher.
My changed rocket improved when I put the fins lower and made them the same size.
Shall I post?
The changes I made to my rocket were the nose cone were too heavy, so I decreased the mass.
The changes I made to my rocket were I added 200 milliliters of water and I moved the
The rocket
fins
by
up.
taking 10 grams of clay off of the nose cone.
I had 80 milliliters of water and the mass of the nose cone was 63 grams. And my second of my rocket was 6.6 on the last launch.
I had 100 milliliters of water in my rocket and the mass of my nose cone was 83 and the time that I got was 8.2 seconds. Right there.
I had 900 milliliters of water in my rocket, and the mass of my nose cone was 83 grams, and my rocket went for 5.37 seconds.
800 millimeters of water, and the mass of my nose cone was 72, and my time of my rocket was 4.7 seconds.
Rocket didn't work whenever my nose cone was too
It
heavy.
didn't work when my fins were too curved.
When I fixed my fins, it worked, but my rocket was sideways from the top and it didn't work that much.
When I decreased the mass of my nose cone, it went higher.
This rocket explains Newton's first law because his first law is inertia, and which is when an object is in motion, it tends to stay in motion, and even when the thrust stopped, the rocket did not stop going up. And it explains the second law, which is acceleration equals force divided by mass. When we took the mass off the nose cone, it had more acceleration. And it explains the third law, action-reaction. Thrust going out of the back end is the action, and the rocket going up is the reaction.